Hydrocarbons. The simplest organic compounds contain only the elements carbon and hydrogen are called hydrocarbons. Even though they are composed of only two types of atoms, there is a wide variety of hydrocarbons because they may consist of varying lengths of chains, branch chains, and rings of carbon atoms or combinations of these structures. In addition, hydrocarbons may differ in the types of carbon-carbon bonds present in their molecules. Hydrocarbons can be divided into aliphatic and aromatic. Aliphatic is hydrocarbon in which carbon atoms form open chains and has no aromatic ring, while arene has aromatic ring. Aliphatic can be divided into three subcategories, which are alkanes, alkenes, and alkynes. Cycloalkane is in alkane subcategory. Alkanes and cycloalkanes are saturated hydrocarbon, while alkenes and alkynes are unsaturated hydrocarbon. As I've mentioned before, aliphatic hydrocarbons have no aromatic ring, and the three subgroups are alkane, alkene, and alkyne. Aromatic hydrocarbons contain aromatic ring, also called arene. The simplest example of aromatic hydrocarbon is benzene. This is an example of structural formula of benzene with molecular formula C6H8 because this structure has 6 carbon in total and 6 hydrogen in total. This is how you draw the skeletal structure of benzene. Saturated hydrocarbon is hydrocarbon that completely saturated. It contains only single bonds between carbon and hydrogen atoms because it has the maximum number of bonded hydrogen atoms. The examples of saturated hydrocarbons are alkanes and cycloalkanes. For unsaturated hydrocarbon is a hydrocarbon that contains one or more double bonds or triple bonds. The examples of unsaturated hydrocarbon are alkene and alkyne. This is the list of general formula for different compounds type in hydrocarbon. For a cyclic alkane, the general formula is CnH2n plus 2, where n is equal to or greater than 1. For cycloalkane and alkene, they have the same general formula where CnH2n. For cycloalkane, the value of n is equal to or greater than 3. For cycloalkene and alkyne, the general formula is CnH2n minus 2. These are the examples of saturated hydrocarbon and unsaturated hydrocarbon. These are the examples of structural formula to represent the structure of organic compounds. Three types of structural formula are condensed structure, skeletal structure, and expanded structure. In expanded structure, carbon chains are usually drawn as straight lines, but one has to remember that Lewis structures are not intended to indicate the geometry of molecules. Notice that the carbon atoms in the structural models of molecules do not lie in a straight line. The structures of alkanes and other organic molecules may also be represented in a less detailed manner by condensed structural formula. Instead of the usual format for chemical formulas in which each element symbol appears just once, a condensed formula is written to suggest the bonding in the molecule. These formulas have appearance of a Lewis structure from which most or all of the bond symbols have been removed. A common method used by organic chemists to simplify the drawings of larger molecules is to use a skeletal structure. In this type of structure, carbon atoms are not symbolized with a C, but represented by each end of a line or bend in a line. Hydrogen atoms are not drawn if they are attached to a carbon. Other atoms besides carbon and hydrogen are represented by their elemental symbols.